This is basics of directional drilling. So the agenda about the directional drilling is and then coordinate systems, surveying well plots, and so on. I try to finish this part in 20 minutes so we can have more time for discussion. And here we have introduction to the directional drilling. The directional drilling is basically just to drill any deviate hole. That means any hole which is not vertical or more than 5 degrees, we can call it directional hole. That's the definition of the directional. If we plan to drill any well directionally or deviated well, we need to have a plan, a well trajectory plan, so we know at which depth where we have to be. In terms of the first column, you see MD, that's the measured depth, because in the deviated hole you have two depths all the time. One is vertical and one is deviated. Vertical is just a vertical depth, imaginary vertical depth, and the MD is the measured depth, which is the real depth of the hole. And then you have inclination. You need to know what kind of inclination you are planning all the way to the TD. And then you have the azimuth, the direction of the hole you are trying to target it, whether it's going to be north, northwest, east, south, whatsoever. And then you have TVD. Like I said, the TVD is the true vertical depth, the imaginary line. Just imagine you're from the surface, from the rig floor to the target, just vertically. And then you have the TVD SS, TVD subsurface. This is the depth. It's usually or always used by the geologist, because if I have several wells on the same location, on the same pad, but the TVD can be changed because it depends on the elevation, how high you are compared to the sea level. So this is the depth related to the sea level, and this is the most accurate depth for to know the reservoir depth and everything else. And then you have vertical section, you have north, south, and east, west, and then you have the dogleg. Dogleg is any change in your inclination degree per a stand, and a stand is about 100 feet or about 28.5 meters. If your inclination is, for example, in the beginning of the stand is 12, and once you drill down the full stand, you have 15. So 15 to 12 that means you have gained 3 degrees of dogleg for that stand, for that interval. And also we have the well path. This is the vertical section. That means this is a 2D. It's called 2D profile of the well. Just imagine if you take a look at the well from the side, you know how you are drilling this well. This well, for example, is vertical, and start building. This is called kick off this point, and then you start building, and then you keep you hold the inclination in here. This is tangent section, and then here again you start kicking off and building. This profile is HKN's profile for the development wells in these days. Applications of directional drills, why we have to drill a well directionally. The main reason in most areas is to penetrate the reservoir more. If you see my mouse, for example, if this is your reservoir from here all the way down to here. Now, if I drill this well like this vertically, I can just penetrate and produce from here all the way to bottom. If this is 100 meter, how about if I drill directional horizontal well like this, okay, and penetrate all the way like this? This is double than this. So if this is 100 meter, this can be 200 meters, this can be 400 meters. So this is the main reason. But apart of that, you have some other applications of directional drilling. For example, side tracking. If you get stuck, you lose the BHA in the hole. Of course, you don't give up. You don't abandon the well. You try to set the whipstock, we'll discuss later on, and then you just directionally kick off from the previous hole, and you will come back to your target again. Inaccessible locations. For example, if you have in Mangesh area, the target was just, for example, was just below the town itself, with these houses and farms and everything else. Of course, you don't want to damage, you don't want to ruin, you don't want to destroy the entire town with farms and everything just to make a hole in there. What you can do, you can drill, you can set your location up at a further location, and then you can directionally drill and hit the target. Another one is just to avoid the soil dome. If this is your target, if you put your rig in here, and if you drill like this, you're going to hit the soil dome. And soil dome is a problematic formation downhole. You usually want to avoid it. So you can avoid it. Just set the rig here, directionally hit your target. Or if you have fault, geological fault. Geological fault means if you have a formation, and then because of some tectonic movements, you have the same formation down below, so it will repeat again. That makes the geologist is blind. It's always good to avoid any geological fault. So in this case, you can set the rig here and instead of here. So this formation repeats in here. But if you drill like this, you don't hit that repeated formation or the fault, geological fault. Or for some relief wells, or if you have a platform, this is a C platform. It's super expensive drilling operation in here. Once you set up the platform, you want to drill maximum holes on the same platform prior to move them. And for drainage, like I said, for drainage, if this is your reservoir, if you see this layer, if I drill like this white line vertically, I can penetrate and produce only this part of this reservoir. But if I drill like this horizontally, this is maybe 100 times more than this, and that's one of the functions. And then also multilateral holes. From one rig, you can drill multilateral. That's another application of that. Well types. In terms of the trajectory, we have about 4 types. You have a vertical hole, just like this one. You have less than 5-degree inclination. And you have S-shape, where it starts as a vertical hole, and then you start building, and then dropping, and then holding. So this is called S-shape from its shape, as you see. This is build section, this is drop section in here, and then this is called a tangent section or hold section. You also have a slant hole or J shape, just a vertical part, and then you start kickoff. You kick off to a desired inclination and azimuth, and then after that you hold all the way to bottom. That's called J. And also you have a horizontal well. It starts as vertical, and then you start kicking off slowly. Like I said, with dog legs, 3 or 4 or 2, it depends on the company's plan. With dog legs, and then in here it's called landing the well. You land the well. That means you reach close to 90 degrees, and then after 90 degrees, you don't have any other directional work. You just keep drilling laterally, okay, just like this. And this is your reservoir. And in this case, if you are successful, you can produce thousands of barrels of oil instead of hundreds. Directional drilling methods. We have some technologies for how we make a hole deviated. We can use a whipstock. A whipstock is usually used for a sidetrack operation. When you have a BHA stuck or geological loss, you can set a whipstock and then you can drill into another direction, or jetting on motor and then stuff. And nowadays we also have the RSS and some other technologies. This is a picture of the whipstock in the warehouse. As you see, this tool, it has a ramp in here, and in the hole, it looks like this. This is the ramp area. It is this area, and here you just running hole with the mills. You just kick off from here, and you abandon this part of the hole. For some reason, you couldn't drill it. You just make another hole and in different direction. Of course, without survey, without knowing what direction you are drilling to, there's no point to drill any well. So that knowledge to know about where we are drilling to is called surveys. Surveys is taken usually by MWD. Every stand, if you are in a crucial area, you can take a check shots. That means several surveys in a stand if you are in a crucial area. So why we need to take survey? You can be within the boundary. That means if you don't have survey, you don't know where you are drilling. If you have many wells like DNO or HK nowadays, we are in development phase. We have only 4 meters different distance between 2 wells. If you don't have an accurate survey, or if you don't take any survey, your wells might collide. So that's why, and construct accurate subsurface map. You can also achieve that from the surveys, and also determine the location and control of the wellbore path and reach a target. Like I said, if you take a look at this is a vertical section. That means this is your plan, and this is the actual. If you take a look at this vertical section, you are drilling this well pretty much in line with the plan. And in here, the plain section, it gives you the same information. Advancements of current technology in the past, in the very old days, I have heard that they used to use some bent crossover, just bent the crossover and use for drilling. But that probably more than 50 years ago. And then after that, they used to use the motor. The motor, you can set a degree for the bend, and then you can just drill with the predetermined bend degree, and then you continue ahead. And that kind of drilling is called slide drilling to achieve your target. That means on surface, as soon as you run the motor downhole, you have no control on the surface. It's just about preset degree. But nowadays you have LWD, MWD, and the rotary steerable systems, the RSS. It can be more precise in terms of geosteering data. Another point which is very important to achieve your plan in the directional drilling is the BHA. The BHA components, this is a typical Schlumberger BHA components. You have a drill bit, and then you have a power drive, which is called the RSS, vortex motor. If you have the RSS, your motor cannot be bent. It has to be slick. That means it has to be on 0 degree. What it does, it gives you only downhole rotation, a part of the surface rotation. So that's all the mud motor is doing if you have the RSS, because the RSS is doing your job, your directional job. And then above that, you have MWD, and then LWD, and then drilling jar, and then heavyweights, and you can have also drill colors in between. It depends on the BHA design by the operator in coordination with the Schlumberger company. Like HKN, our drilling engineers are in contact with Schlumberger in terms of the jar placement, where we need to put the jar, and also the other components of the BHA. The rotary steerable system is a general name. RSS is a general name. It doesn't belong to any company. RSS is the newest technology of directional wells. With RSS, you can control your directional, the inclination, and also the azimuth, the direction of the well you are targeting can be done by the RSS. And you can control that. The good thing about the RSS is you can control on surface. That's why we have the RSS engineer or the directional driller on the rig site whenever we have that tool in the hole. He's responsible to, they call him downlink, that means giving command. It tells the tool, go this direction, this inclination, and everything else. But for specific Schlumberger company has their own commercial name. For example, Schlumberger calls it power drive. Halliburton calls it GeoPilot, things like that. But the only difference is RSS is general name. You can control your directional on surface by the directional driller or the RSS engineer. MWD is measuring well drilling. In MWD, you have it above your RSS or power drive, or if you have motor, you can take surveys with MWD, and after each stand, and or like I said, if you're in a crucial area, you can take several MWD readings per stand, so you know if you are in line with the plan or you're deviating from the plan. You can make correction anytime. The advantage of the MWD, you can always take a survey. In most cases, if you don't have any magnetic interference or any interruption, you can real time see where your bit is going to. You can real time see without taking any survey. But you usually take survey after each stand just to confirm. And it's 100% reliable. There's no problem in MWD. The LWD is logging while drilling, like as we discussed. The LWD can be placed also with the BHA just above the power drive and the motor. If you have the motor, or above the MWD, it depends on the operator's company policy. It's logging while drilling. And instead of, like I said, I mentioned before, all wells in the interested area, which is the 6-inch hole, it's over 45 degrees. And we have a lot of hole problems, like loss, like washouts, like overgauge, like caves. So it's very, very risky to run the well line. Even if you run it, there's very slim chance to be successful because your hole is already over 45 degrees. The wire cannot push the tools down. So in that case, we have LWD as alternative to take the data gathering in for the geologists. And also that the LW same as MWD, most of the time they have the real time and they know, they can see basically, because most of the LW tools has a tool called image tool where you can see, you can interpret the formations, and the geologist can decide which direction we have to drill for. Okay, directional drilling limitations. Of course, like any other drilling practices, directional drilling has some limitations. The first one is torque and drag. Of course, it's totally different than if you drill a hole vertically, you can control your torque and drag, and you usually have an ignorable torque and drag. But you can imagine if you start drilling towards a horizontal path, like around 90 degrees, all those pipes and all those tool joints, bits, stabilizers, and everything else is going to be landed on the ground. So of course, when you rotate, you make more friction. The drag is another term of friction. You make a lot of friction. And torque is also, you need a lot of rotational force, which is called torque, to forge ahead with your plan. So the pipe and the other downhole tools has a limit for torque and drag. You cannot rotate your pipes with unlimited value. Any pipe and any other tool has a limit, has a value where you cannot exceed. The hole cleaning, it's like we mentioned yesterday in the drilling fluids part. If you have a vertical hole, it's easier to clean and carry the cuttings back to surface. But with hole cleaning, if you are over 45 degrees, because of the mechanism of the cuttings settlement, it's hard to take out all the cuttings and clean the hole properly. The depth heat with the motors. And in Kurdistan, we don't have that big problem, but in some areas, the downhole temperature is so high, it can create the cracks in the failures on the downhole motor and the other MWD, LW tools. Another issue is, if I go back to the BHA, and here you see you have the bit and then the power drive and the vortex, and then you have MWD and LWD. The MWD is usually about 25 to 30 meters above the bit. So what you see real time, or you take survey for MWD or LWD, of course, you don't see the information at the bit. You see at least 25 meters above the bit. But now you're in reservoir. You might have fault, a lot of geological problems. You would like to know just above the bit, but most of the time you don't have that information. You have it 25 meters above the bit. If you want to know the information at the current depth for the bit, you want to drill another 25 meters. And another 25 meters can cause hitting a fault or some other risks. But now there is a tool they call C-Link. You just put it on the bit. If you are lucky, you can get the directional data right on the bit, if you are lucky, if it's working. That was the directional drilling limitations, and also the air drilling with motors and LWD. Of course, like we said yesterday, all the directional tools in MWD and LWD are taking advantage in terms to two points from the mud. First, the mud powers up the tools. It gives the power for the battery and everything else. And also it gives you the pulse. You can read the LWD data. But with air, you need to use another tool they call EMWD. Okay. In this case, it's going to be harder to use the MWD, LWD tools if you use air. And apart, like someone questioned, if you have a high temperature well and using air, you don't have anything to cool down all these tools. They can fail at a sooner time. So these are the limitations, we can call them, of the directional tools. These are some studies about the highest or the deepest well they've achieved with one run of the motor and stuff like that. It's not a typical information for this section. And then we have another term which is called geosteering. Geosteering means if you have the directional tools like power drive or RSS with LWD, you have someone, they call him geosteering scientist. He can have a big idea about where we have to drill, and then he basically drives the drilling operation in the reservoir section. The drilling people, they just work for him because it's so precise, and he needs to be very careful to avoid soil domes, to avoid the geological fault, to avoid the oil water contact and so on. So that was the information, basic information about the directional drilling. Now we can take the questions and we can discuss if there is any questions.
Thank you, Kak Haman, for this run of seminar. It was very informative. So, Dijans, if you have any question, you can ask. Go ahead.
Yeah, I think we have about 15 minutes this time.
Yep.
Even more.
Any question?
Hello, Mohammed.
Mohammed Akram, go ahead.
Mohammed?
Yeah, Mohammed Akram, go ahead.
Yes, go ahead, Mohammed Akram.
Before anything, thank you, Kak Haman, for your explaining through all these 3 days and also for your information. Just I have a question about the direction of the drilling. If we know in the reservoir we have the oil with high viscosity, we like to use the directional drilling or the normal drilling, and why?
If you have any kind of hydrocarbons, gas wells, and anything else, you can use the directional tools. And it depends. Okay, if you compare the directional tools like RSS to the conventional ways, if you use the motor, just the motor for directional, the comparison can be done. The directional tools are super expensive tools. Okay, just one tool, just RSS tool, the daily cost, Kak Ahmed knows, our well site engineer, it is equal to the rig cost, the entire rig cost with the crew, with the mechanic, with all those equipment. Just one tool is equal the same daily rate. So it's very super expensive, and also it's very risky. If you face any stuck pipe problem, if you lose your BHA, it can cost you millions of dollars. But on the other hand, with the RSS, if you compare to the motor, it's totally different, because with RSS you can control on surface anytime. You can drive it. That's why it's called steerable. So you can steer it just like your car. And also it's very precise. And also it gives you faster drilling, much faster drilling compared to the motor. So these are the advantages in this. But if it's up to me, I would always use the RSS tools for drilling the directional part in our wells, because it's more beneficial than motor. It doesn't matter the viscosity of the oil.
Okay, thank you.
Thank you, Kakiman. Any other question? Kakilan, I think you have a question. He has written it down. Kakilan says, in multiple reservoirs with one start point, I mean, a single well, one reservoir is directional, how we the casing plan, and both of them have the same plan in the point deviator. Kakilan, can you unmute yourself? Okay. Any other question?
من بسیاری هایی اگر رخصت بیتم البته بچک بسیاریت من
Okay.
اوکن
But,
سپاس که
Mr.
من
Abdul, please specify it because maybe other participants also may have any question else.
اوکی اوکی
بله
Go
بله
ahead.
فرمون.
Yes, Mr. Abdul, go ahead.
سپاس که من کاک محمد بودجی سپاس از کردی آخوام چون پتر لباجداریت ما پتر کردی تید گن حتی انگلیزی چون انگلیزی ها خوش بوما کیشه دیساجی سپاس بسیارا من یک اوه که بسیار جماعت یکرن اینچه وان زانن بیتیت هوا خراب بن یا اوه هوا پرکتیکال لکیش ایچ که اندا بیت خراب بویا که بری بگن سیکشن اکینگ دریخن زانیاریت که هنگ زانن آروپیه چیه کاتینگن جنس کاتینگا هوربینا کاتینگا چیه هنگ پرکتیکال گنه که بیت خراب بید دریخن دوباره رانینگ بکن یک بسیار اوه اگر زحمت نوید که من کرم کرد
اوكي سباس كاك عبد السلام بشارك جوان انديكيشني ك بيت بيرفورمانس بارني يكمش وبشكل عام اوروبيا خاصه لديفلوبين مثلا اما ل 2019 سه بیرمان حفر کرد باشە دوو بیرمان حفر سێ بیرمان حفر کرد هیچ چارەم دەزانین ئەو بتە پێرفۆرمانسێکی زۆر باشیە بۆ مەسەلەن ئاڤرێج ROP 25 بووە ئێستا دەبینین ئاڤرێج ROP بۆ نفسی بت و نفسی فۆرمیشن 7 دەیە دەزانین کە ئەو بتە مشکلێکیە یەکەم شت ROP دووەم شت دەتوانین بڵێ لە دایرکشنال خاصن PDC ئەگەر خراپ ببی خاصن ئەگەر ئاوتر کەتەری خراپ ببی ناتوانین دایرکشنال کۆنترۆل بکەی یعنی هەر چەندەکەی ئینکلینیشنی ئەوەی مەطلوبە ناتوانین بگەیتە ئەوە سەبەبێکی دیکەیە سەبەبێکی دیکە دەبینی احتیمالە تۆرکت زۆر زیاد ببی دەبینی تو ئینکلینیشنت زۆر نییە مەسەن 35 دیگریت هەیە بەس دەبینی تۆرکت زۆرە احتیمالە بتەکەت خراپ بووبی هۆڵەکەت ئەندەرگەیجە خاصن ئەگەر ستێبلایزەر هەبی دەبینی بتەکە سایزی ئەندەرگەیجە و ستێبلایزەر فول گەیجە تۆرکێکی زۆر دەبی سەبەبێکی دیکەش دەتوانی بزانی حسب expectationی خۆت مثلا ئەگەر لە های تمپرچر وێڵ بی تمپرچر عادەتەن کراک و تەسیری زۆر نێگەتیڤ دەکاتە سەر بت بەس بە شکلی عام تۆرک و ROP یەکەم شت دوای بە تۆرک دەتوانین دوای بە دایرکشنال کۆنترۆل ئەوانە هەمووی احتیمالی ئەوەن کە بتەکەت خراپ بووبی.
Thank you, Kakiman, and thank you, Abdulsalam. Abdul Khabir says he has a question.
Thanks a lot, Mr. Himman. My question is about operating BOP. At the first seminar, you said that we operate BOP by the CUMI unit, and when I studied, I see the accumulator. So are they the same, or are there any difference between them?
Okay, they are exactly the same thing, but CUMI unit is the commercial name. The CUMI is the name of the company, but the accumulator unit is the general name. That's good. Same as we call RSS, we call it power drive because Schlumberger calls it power drive. And CUMI unit is the same. Accumulator unit is exactly 100% the same, but the CUMI is the name of the company. But Kak Mohammed, if you give me a second, just
do we use just
a minute, Abdul Khabir. Yeah, Kakiman.
Okay, just before I forgot, شاركي كاك عبد السلام لسروي بچی دزاین بتخرابو بس پیشوی تو ROP دبینی کما یا دبینی تورک زور یاشتر یکسر قراری اون ندی پول اوت بکی پارامترکان دگوری دریلین مثلا RPM هەفتە دەکەیتەوە دەکەیتە هەشتا دەبینی بزانی ویت ئۆن بتت مثلا کەمی دەکەی زیادی دەکەی فلۆ کەم دەکەی زیاد دەکەی حتاکو هۆڵ کلینینگ باشتر ببی یعنی لە ئاڕۆپی دیکەم بوو یا تۆکردی زۆر بوو یا مشکلێکی لەوە ڕائسن قرار نادێت بدەکەت خراپ بۆ پڵاوکەی پێی دەڵێن درلۆس تێست پارامیتەرەکانت دەگۆڕی حتا بزانی کامیان باشترین پارامیتەرە RPM دەگۆڕی ویتۆن دەگۆڕی GPM فلۆ دەگۆڕی حتا يعني you do your best بس حتى pull out نەکەی ئەگەر زانیت بە ئەنواعی پارامیتر بتەکەت هەر پێرفۆرمانسی باش نیە ئەوجا قەراری pull out بدەیت.
خوش. عبدالخبیر توابو اگر کسی از بسیار منتهی بگم کیف
Actually, Yusra has a question, Mr. Abdulsalam.
Go ahead.
Kemen Yusra is asking a question, and she says, my question is about salt domes, because we know sometimes they associate it with petroleum reservoirs and make problems during drilling operations. Can you please tell us some problems that encounter our engineers in Kurdistan, even in HK and Bloik? Do they have salt domes associated with their reservoirs? No.
That's good. In terms of salt dome, we don't have any salt dome issue in HKN, and according to my information, entire Kurdistan, there's no problem for salt dome, but the biggest geological problem is the faults. In our reservoir, sometimes we hit 3 faults, and we are doing our best. We have all these LWD tools, but still many times we've hit faults. And once we hit faults, we can create issues in even in the development phase. For example, well number 8 in one area, we still hit the fault and then we hit the water. So, and then now we have to solve that issue with the completion tubing. We need to stay away from the water. But the salt dome, yes.
Sorry for interruption, but Siraj Muhammad says he has a question. Yeah, Kak Siraj, go ahead.
Hello, Kak Muhammad.
Thank you very much.
Thank you, Mr. Heyman. Just my question is, after abandonment, after removing surface facilities and plugging the well, do you put any thing like brine water to replace the oil that has been produced?
Okay.
Environmental impact.
Yes. Of course, before you abandon any well, so far HKN has abandoned the 2 wells, Gara well and the Mengesh well. What we do in any potential reservoir where you can expect the oil and gas, you need to set either a bridge plug to bridge off anything below, or you need to put a cement plug. We just, instead of KCl or any salt or anything like that, we need to put cement, and the cement height in the well can be calculated easily how much you need to put. And then above that, yes, it can be salt, it can be mud, it can be anything like that. And mud is cheap. If you abandon a well after spending millions of dollars, you can put, about $2,000 cost of mud in the hole just for the environment concerns.
Okay, thank you.
We've got 3.5 minutes if there's...
Yeah, exactly. So, Kemen, actually, I have a question too. My question is about setting casing in the inclined portion of the well. Does this material, that section of casing, flexible? So supported in the inclined portion of the well.
The case, yes, there is no problem for casing. The casing is so flexible; it's much more flexible than the pipe. It can take the shape of the whole trajectory at any point, not even at the deviated part. We use tubing, which is a smaller size of casing, even for 90 degrees. We've set tubing at 300 meters of the horizontal section. So can you imagine your hole is going like this, but the tubing is also going like this. So it's quite flexible to be in shape of the hole.
Okay,
No problem.
Sha'lan asks which type of bits you are using according to the formation. For example, you have shell formation or whatever you have been faced.
Your voice was breaking, but what I understood from the question is what kind of bits we use, right?
Yeah, for example, shell formations.
In all formations, we use only PDC bit because, like I said, I'm talking about the HKN because it has proved as the best bit for us. But this is not a random PDC bit. We have designed our own bits according to our formation challenge as well. So we have our own design for the PDC bit, and we use only PDC bit for all sections. It doesn't matter, shell, limestone, dolomite, whatsoever. We've got about 1.5 minutes.
Yeah, exactly. Actually, I'd like to end it up with an Indian speech. As you know, as the time goes fast, the introduction to drilling engineering and directional drilling course is coming to its end. Hopefully, the content of the training was systematic and comprehensive. The theoretical knowledge was closely combined with the practical work. Information, current and future problems were well integrated. Thank you, Kak Hemen, for this informative seminar. Actually, I'd like to express my gratitude to you for sharing your knowledge, and to Kak Ahmed Rashid too, for his coordination with us for preparing this course. And I'd like to welcome and express my gratitude to representatives of Koya, Kuma, and other Kurdistan universities who have participated with us. Hopefully it was a useful and informative training course. So less than 1 minute left. Once again, thanks, Kak Hemen.
Thanks, Kak Mohammed. Thanks for everybody.
كمان بس باديني دو جملة بوم بيجا.
My Badini sucks. It's a very broken Badini, so I better speak just English. I think that's better for everybody. Otherwise, they will be confused even with my English. All right, guys. Thanks so much. Thanks for everybody. I hope this has been a useful presentation or seminar or whatever you call it. And then I hope I will meet